Hi everyone. I'm checking the stream on my mobile if the audio and everything is fine or not. And then we will get started with some like graph problems. Yeah, the audio seems fine to me. Let's just verify it once more. So yeah, audio is fine. What I want is the live chat probably and details. We go. These are the analytics advanced mode. Okay. Let me go to my channel and here I see the stream. I just want this live chat. Pop it up. Yeah. Live chat. Let me try to adjust this thing. Mm, okay, more actions. Keep above the others. Uh, yeah, this looks fine, I guess. And increase this a little bit. Yeah, we're good now. Okay. So, hi everyone, whosoever is joining the live. Let's wait for a couple of minutes if people join. Today we are going to solve like bunch of graph problems. I've opened like a lot of problems, but okay. So Wrench 2474 says, "Yo, hi." We are going to start with these graph problems. These are too many. I can't solve them in like a single stream, but there are some problems that are on this topic, which is minimum spanning tree on Dijkstra's algorithm, on the disjoint set union we have, right? So these are the problems. Let's start with the first one, graph valid tree. So I'll give you the problem link as well if someone wants to solve. Uh, Graph valid tree. So you have a graph of n nodes labeled from 0 to n minus 1. You are given an integer n and a list of edges indicates that there is a undirected edge between nodes ai and bi in the graph. Okay, return true if the edges of the given graph makes a valid tree and false otherwise. Okay, so this looks like a valid tree. This doesn't look like a valid tree, and the reason why this particular tree is not valid is what do we have? Okay, let me get the setup fine. So we have 0, 1, 2, then we have 3, and 1 is connecting to 3, and then we have 4. The problem is this. This is a cycle, right? This is a cycle. In a graph, you can have cycles, but a tree is just a acyclic uh, graph, right? A tree is a acyclic graph. It shouldn't have cycle. And is there anything else that we want to check? Can we have like okay? Um, my concern is can we have like something like this 0, 1, and then 2 and 3? Do we have disconnected like components? This one is VIP. I can't solve it sadly. Okay. Do you want to skip over this problem because this is a pretty easy problem. You have to just find a cycle. For finding a cycle, we can use DFS, we can use union find, and we can also use BFS. We have these three options. So I'll skip over this problem since this one is a premium one, and we'll move to the next problem. I've already solved it. I can quickly go through the solution. Also, like I don't remember what approach I chose. All components are connected. So yeah, this was my concern. So we have to check all components are connected and there is a no cycle, right, in the graph. So we create a adjacency list, right, and then we call the solve, and we count the visited. If visited is equal to the n, that means you uh, yeah, I am decent. I won't call myself like very good, but I have somewhat around 600 problems solved on the platform, but that was like through many years. Yeah, but I need to give more contests probably. I'll last contest I gave like was 2025. I need to improve my ranking, this contest rating. Right, and yeah, this is my profile, Leetcode profile, and yes. But over time, you practice, you get the hold of things, how you do things. So we do a visited, and we want to check that if you start from a node, let's say 0, you are able to visit all the uh, what you say, all the vertices, or yeah, all the vertices. So that's how we can do this. And for finding the cycle, what I did was I used DFS. So this is the code for DFS. uh you pass in a parent also, I think, in this one, yeah, because you don't want to say if I have since this is a undirected graph, I don't want to say something like this, that 0 1 and 2 if we have, and you are doing a DFS from here from 0, then you visit 1, so in one neighbor you will have 0 as well, right, because this is a undirected edge. So you don't want to say that if from 1 to 0 there is an edge, then 0 to 1 there is an edge. That's a cycle, because that's not a cycle, right? There is just an edge between both of them. So you want to keep a track of a parent, and whenever you find the neighboring edges in the parent, uh, you don't want to handle that as a cycle, right? You don't want to say it as a cycle. So I think this is a pretty easy sort of a problem if you have done graphs earlier. Right, let's do one thing. Okay, yeah, let's skip over this problem. I'm not going to solve this. This is an unsolved problem, so I'll probably struggle more on this. So this is the next problem that I'm looking to solve. uh let's read through the problem and try to understand this one. uh in the chat, if there's anyone, if you have any sort of questions, you can throw them at me. It can be regarding anything like graphs, DSA, career, resume. If you have want me to do a resume review, you can send me your resume as well. I have around like four plus years of experience, so I can give you some insights based on that. Okay. So this is problem number 1615, which I've sent in the chat as well. Uh, let's read this. So there is infrastructure of n cities with some number of roads connecting these cities. Each road I is this AIBI, indicates that there is a bidirectional road. So this is an undirected graph. Bidirectional we have the road between the city A and BI. The network. Sorry. There is a alert on my phone. Yeah. Damn for okay. Which company do you work in, by the way? I work at Oracle right now. Yeah. Damn for plus. I am last year college student. Okay. So, what you are you currently preparing for your placements? I think the placement season is going to come now, right? Hmm. Yeah. So let's look at the problem. The network rank of two different cities is defined as the total number of directly connected edges to either city. If a road is directly connected to both cities, it is only counted once. The maximum network rank of the infrastructure is the maximum network rank of all pairs of different cities given the integer n and the array roads return the maximal network rank of the entire infrastructure. Okay, okay. How is the preparation going? Uh, any topics that you are facing issues in? Okay, let's look at an example easier to understand. So we have n is equal to 4, so we have 0, 1, 2, and 3. There is this roads. Okay, then I haven't done many DSA because I was too much into cybersec doing hack, hack the box. Started doing DSA again for placement. Oh, that's good. I don't know much about cybersec, but I am in a backend role. I haven't been doing cybersecurity, but I don't know how is the field for freshers and all for cybersecurity. Right now, the market in general is like pretty bad for freshers, to be honest. The network rank of city 01 is 4. Okay. City 01 is 4, as there are 4 roads that are connected to either 0 or 1. Okay, I don't understand this problem very well, but let's try to read through this explanation. The network rank of cities 0 and 1 is 4. Um, okay, why is it 4? As there are 4 roads that are connected to either 0 or 1. Okay. The road between 0 and 1 is only counted once. Okay. What is the next example that we have? N is equal to 5. We have this. Yeah, backend is pretty interesting. Backend is very interesting. Cybersecurity, yeah. Maybe you go from like a backend role to a cybersecurity, then it's more accessible or easier, right? Rather than going directly into cybersecurity, because I don't see a lot of company hiring freshers for cybersecurity. Yeah, so this question is a bit tricky to understand at least. There are 5 roads that are. I want to draw this one. So what I'll do is I will draw this. So we have 0, we have 1, we have 2, and then we have 3, right? Uh, 0 and 1. So there is one road here, and there is one road here. This is second. This is third, and this is probably counted as the fourth road, I guess, right? So this is one, this is two, this is three, and then we have a fourth one. Okay, okay. Um, yeah. Yes. I had a question, by the way. How are you guys prepping for the mythos? It might be something, or might be nothing in any plans for it. I'm not preparing anything for it. I see it as more like a marketing hype sort of a thing from Anthropic, because they keep on saying that in next 6 months the software engineering role won't be there, but it's been 2 years since then. So yeah, I think it's a marketing tactic that they have. Yeah. Yeah. Okay. And since we can't do any like prep for that, if it is there, then it is there. There's no, and even though if actually exists, maybe the cost of running it is very high. So that's why they are not giving it to like everyone out here. Um, right. This question is, I want to draw one other example. We have two, we have three, and we have four. Okay, these are the edges that we have. There are five roads that are connected to the cities one or two. Okay. What is the constraint on this one? The constraint is pretty small. So I think I can do n square or something like that. DFS on like every edge, every node. Uh, I want to reread this. The network rank of two different cities is defined as the total number of directly connected roads to either city. The network rank of two different cities is defined as the total number of directly connected roads to either city. Directly connected nodes to either city. Okay. Let's look at this example. It says cities 1 and 2. So this will be 1. So this will be one road. This is going to be a second road. So this is 1. This is 2. Then this is again one more 3. And then we have this 4 and we have this 5. Yeah. Hmm. I don't know. This is pretty difficult to understand. What do people say in the discussion? Yeah. Okay. People are like confused like I am. So I'll read some discuss. Actually is total number of roads of the pair A and B is equal to count of road to A, count of road to B minus 1. A connect to B. Okay. One. No. I don't get this problem to be honest. Uh, I want to see if someone is explaining this. Hmm. Yeah, the description is pretty bad for this one. Uh, yeah. Okay. Question is essential about how many cities a given city is connected to, and for all city pairs combo, what's the max total connection? Okay. If I try to understand it this way, uh, for 0 and 1, we have a connection from here, so that is 1. We have a connection from here, uh, right? Then We have this connection. So this connection, like you go here and then back, right? Um, so these are like three, but why is the answer four? Okay, there's a direct connection as well. I don't know if I counted it or not. So one is like the direct connection. Uh, Second is this connection. Then what else do we have? For zero you go to three and then you go to one. Zero, one, two, and then you can go back to one. The network rank of cities 0 and 1 is 4, as there are 4 roads. So one, 2, 3, 4. This is probably counted as 2, I guess, right? Oh, okay. So this is one, 2, 3, and 4. And for this one, it will be uh, 4, 4, 4, 4, 4, 1 and 2. The roads that are connected to cities 1 or 2. So for 0 and 1, there will be like 1, 2, 3, 4, 5. Okay. And yeah, for 1 or 2. 1, 2, 3. For 2 and 1, if I draw it again, like 0, 1, 2, 3, we have 5. So for this one, for 2, if I count, um, like there's this road which is 1, there's this road which is 2, there's this road which is 3. uh then we have, okay, I don't understand this, so I'll go probably not wasting much time to the solution. Yeah, let's see some solutions. Okay. um I was kind of thinking about like an in degree and out degree sort of a thing. Uh, Try every pair of different cities and calculates its network rank. Your degrees, I think, plays role in this question. The in degree and the out degree. So, what people have done is you calculate the in degree and out degree. No, this is just the in degree, I guess, right? Connected is true. Okay, R0 connected to R1 is true. They've taken a matrix here, and for int equal to 0, all the other pairs. If it is connected, then we do a -1. If it's 0, I don't like this question, to be honest. I'm going to skip it, and we are going to probably move this at the end. Or else skip this one and do this next question. This is hard question. Let me check. Yeah. So next question is minimum number of vertices to reach all the nodes. So what I want to do is I want to solve this problem like later on. So um, I'll solve this problem like later. Let's do this question. So minimum number of vertices to reach all the nodes. Okay, given a directed acyclic graph with n vertices numbered from 0 to n minus 1 and an array edges where edges of I is equal to from okay, directed graph we have, right? Find the smallest set of vertices from which all nodes in the graph are reachable. Smallest set of vertices from which all node of the, it is guaranteed that a unique solution exists. Notice that you can return the vertices in any order. This seems simple. Um, okay. How I am thinking for this question is something like this. So we have a 0, we have a 1, we have 2. Here we have a 3, then a 4, and then a 2, and a 5. Right, this is what we have. Um, so this is a very famous algorithm, topological sort. You can use that, right? You can use that to find out like which nodes are there. It's not exactly a topological sort, it's a variation of it. But a very simple observation in this question to make is you count the in degree, right? The in degree for this is 0 and this is 0, and this will be 1. This has 1 and 2, this is 1 and this is 1. So any node that has an degree, that means there is no edge going into that node that is required. That vertex is probably required to traverse all of its neighbors, right? So you count the in degree. You say if the in degree is 0 for any node, you make it like what the question says, necessary edge, right? So let's solve this question. Let's solve this question. Yeah. This should be pretty simple question to solve. Um, so we have a list of integer new array list. Return this result. What we want to do is calculate the degree. Ending new 10 for list of integer edge and edges. So int u is edge dot get 0, v is edge dot get 1, and we say in degree of v plus plus, and then you traverse through all the edges. If the in degree of the edge is 0, then you say result dot add the edge I. Yeah, so we are able to solve this problem. Yeah, I think this marks my 600 question, I suppose. Yeah. So finally we have solved 600 questions. Right. Uh, if anyone else also want to solve this question, this is the question that I just now solved. Possible bipartition. This is a solved question. All right. This is the question now I'm going to solve. And is there anyone in the chat? Let me check. So you go to content and live. I want to see the stream manager control room. Okay. Um, I had some viewers, but they probably left or something. If you are in here, do say hi, right? And yeah, we can chat. Possible bipartition. What does this question says? We want to split a group of n people labeled from 1 to n into two groups of any size. Each person may dislike some other people and they should not go into the same group. Okay. This strikes me like at any day of the time. Uh, this seems like you want to partition like into two groups. You have a person here, you have a person here, you have a person here. This person can dislike this person, but this person can't dislike. So there shouldn't be any edge between this. This is wrong. Uh, this is a classic union find problem. So I think we can use that to solve this problem. We can define two sets, and no two sets should have same number of people. You want to tell if it is possible to split everyone like this or not, right? Let's let's do a union find. So parent, and I'll do a rank. Uh, rank. What I'll say is parent is new integer of n. Uh, okay, and a rank is new integer of rank. For int I equal to 0, I is less than n, I plus plus. The parent of ith node will be I itself, right? And we have dislikes. So for int dislike in dislikes, and u is dislike of 0th, v is dislike of first, u and v. If the union of u v gives me true, if it is false that you can't union them, then you return false, otherwise you return true. Let's write the uh, find function. If parent of x is not equal to x, otherwise return parent of x, then parent of x is equal to find of parent of x. This is our find. We are also going to write union by rank, and that will be int u and v, uh, or I like to call it x and y because that's how the code is in my mind. And parent of x is equal to find x, parent of y is find y, and if they belong to the same set we return false, otherwise we return true. We do the union. So if rank of parent of x is greater than rank of parent of y, then what we do is, so x rank is more, that means parent of py is equal to the px, else if rank of px is less than rank of py, parent of px is equal to py, otherwise we say parent of anything works here. Px parent is py and the rank of py will be incremented here, right? Let's try to see. Okay. Oh, this will be n plus 1 then. This will be n plus 1 arrays. I got a false. That's strange. What did I do wrong? Hmm. Is it going to be like this? No, 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 no. Maybe I'm writing this wrong. This is Union Find, right? Let's see how I have previously written. Um, Status is sold. I've solved Union Find questions. This is weird. Right. Let's see. Let's see the example that we have. This is a big example. This is fine. This is fine. Hmm. Rank initially will be 0. Let's try to see where we are returning a false. hmm, Maybe I'm doing this parent thing wrong. Hmm. Let's print out the parent as well. Parent array. Hmm. 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 I think I'm doing it fine. What the show? Okay. The union find is okay. Yeah, thanks. Thanks for tuning in. Hmm. Hmm. Maybe there's an issue in my find function. Hmm. Let me rewrite this one. So if x is not equal to parent of x, or if x is equal to parent of x, then we simply return parent of x for x. Otherwise, we say parent of x is equal to find parent of x and then return parent of x, right? I think my find is also fine. Hmm. Let's try to do one thing. We can have four. We have 4 over here, 7 over here, 4 over here, 8 over here. We have 5 and 6. 5 goes here, 6 can go here. 1 and 6. 6 is already here, 1 will be here. 3 and 7, 3 will be here. 2 and 5, 2 will be here. 5 and 8 is already present. 1 and 2. Now this is the problem, right? 1 and 2. But 1 and 2 already should be like different. How come parent of 1 is 7? I don't get that part. Hmm. Then the issue is here. Hmm. I want to take help. Union by rank and path compression Java. Mm, 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 We try to do some dry runs. So 7 and rank will be 1, 4 and 8. How is this possible? How is this possible? Should I be sorting or something? I don't know. Will that make a difference? Hmm. 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 I can't solve this. What's the issue here? Ooh. Okay. Okay. I get it now. So, yeah, I don't want to do this union. So, I have to do this union. So, basically, what I have to do is I have to do a union of like U, comma V, and if they are in the same set. Hmm, I don't get it still. Like, why is this wrong? No, I don't understand. Let's try to go through some editorial. Not BFS. I want to do the not approach to union find. Yeah, to see the union find. Okay. Hmm. If you and we are in the same set, then it's a problem. Probably my implementation is correct. Mm, let's do this thing. And then add stored compute if absent v new array list, add u. Now for all the nodes starting from 1, if not adds dot contains key u, continue, and if it contains a v, I do not get u. We check if parent of find u equal to find v, will return false. Otherwise, we union. That means. Oh, so we are creating like a set of dislikes. This two sets we are creating, and this we are putting all the people. No, uh, yeah, in v u comma v. So when you union u comma v, there will be an dislike item here, right? Okay, or you union them. So for this, 4 will have 7 and 8 because 4 dislike 7 and 8. Oh, I think I get this one. See, you don't do V here. You do add dot get u dot get 0. Right, this is what you do. Because you want that if there is 4 7 4 8, these should be part of the same group, not these should be part of the same group. This is right, this is wrong. Okay, I get it now. But this was a good question. uh let's see. This was a good question. I'll add it to my revision list. I've already added it, so yeah. Next question. So next question is, I've solved these questions. No, I might. Yeah, I'll write the code. Um. Anyways, I can close this one. I can go to my studio. Live chat. My internet is getting slow for some reason. Hmm. We had one user, but I think they dropped. Let's just continue with our problem. So is graph bipartite. There is an undirected graph with nodes 0 to n minus 1. We're given that 0 is connected to 1, 2, and 3, 1, 2, and 3. 0, 1 is connected to 0 and 2. Let's create a map of integer list of integer out of this. You new array list. So this is very similar to the last problem that we solved. um I'm writing like this boilerplate kind of a code, and then I'll tell you the problem. Right, we have the graph now. mm, okay, so we have uh graph like this: 0, 1, 2, and 3. We want to partition this graph into, like, we have to make a bipartite graph. What I meant by bipartite is there should be a set of like nodes here that should have a connection with a set of nodes here, but they can't have a connection here. So what we will do is we'll take 0, any of its connection we are going to put in one set, and it's very similar to the last problem that we solved. And this is the problem link. Okay, for int, what we can do here. Hmm. So in this u is 0. Okay. Uh, Here I think it's different for int. Oh, it's one of those problem. Hmm. It doesn't contains continue. Otherwise, we say I don't get you. Um, I've not union नहीं हो पाया. That means union didn't happen. In that case, we will say say, or we can do like find of you false, and then we can union the hash dot get you dot get 0 to be. I think this should be fine. Let's try and find if x is not equal to parent of x, return parent of x is equal to find the parent of x is uh, parent of x. And union and x and y, and px is px, find x, and py is find y, and if px is equal to py, simply return. If rank of px is greater than rank of py, then we say parent of py is equal to px. Otherwise, if rank of py is greater than rank of px, we say parent of px is py, otherwise we say parent of px is equal to py, and rank of py plus plus. Let's see. Let's see. Mm, okay, this says false expected is true. No, I'm writing it wrong. Hmm. This is not going to work because you and we can be in the same set, and I'm trying to put them in the same set again. Hmm. The solution was correct. I think this was wrong. Yeah, my solution was correct. I think this is also a very similar problem, so I won't be solving it. And this is also the same problem. Um, let's do hard. I don't know if I will be able to solve it by my today's performance. Let's see how things are going. Okay. Right. So next question is similar strings group. Two string x and y are considered similar if either they are identical or we can make them equivalent by swapping at most two letters in distinct partitions within the. Hmm. They're anagrams, I think, but no, not anagram. Okay. I think this in itself is a question like, can you make two string equal by swapping at most two letters? Oh, anagram can. Hmm. Okay. If they are anagram, then I think the observation here will be that swapping like index of one character differs, right? So if I take an example, Hmm, like we have towers and rats. So this is same, this is same, this is different, this is different. But there are only two position which they differ by. Then you can swap them and make them equal, right? Hmm. So I think that question is solved. Like one part of this question is solved doing that. And the other part is says that uh so n square I think we can do, right? Yeah. So we have something like tars, rats, arts, and then we have the star. So for this, I'll go through this, go through this, and go through this. Is it one diff rat? So tars uh, and rats will come in one set. So this is another set. Then tars and arts. So this differ by one position, two position, three position, which is not correct. Right, so they don't come into one set. And then we have tars and star, which differs by more than two positions, so they also don't come in. Then we have rats and arts, right? And rats and arts differ by like two characters because we can swap it. So they now belong to the same set. So what I can do is I can union the what you call rats and arts. So these come here, arts come here. Now for arts, then this no. So yeah. Two. What is this answer? How many groups are there? Notice that there are these form two connected group by similarity. Uh, this is not a straightforward union find. This is tricky because how do you give the answer for rats? So tars is done, rat is done, arts is done, and star can be here, right? Two groups. What we can do is like a union find and then we can do something. Just give me a moment, please. Okay. I can find unique parents. So in this case, parents of all these three will be like one number X and this will be Y. I think I can do this. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, da, da. Da, 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 da. Mm. Mm, mm, mm. Just give me like a minute, I'll be back. Okay. Parent of y, find of y. If parent of x is parent of y, return. Um. पहले से ज्यादा Okay, so valid is when the difference is less than or equal to 2, right? And let's try to run this code. Okay, we have u total length, v. Hmm. Mhm. Hmm. Sorry. So, I think this is enough number of problems for this live stream. The live stream has been going on for let's see, uh, so almost 2 hours we are done with the live stream. And yeah, that's all for today's live, and we will be solving more questions in the next live stream, probably more graphs question that we have over here. That's all for this live stream. Thanks a lot.